What if I told you that ideas like Pascal's triangle, binary system, and Fibonacci sequence were already being explored in India over 2000 years ago? Not through equations, not through symbols, but through Sanskrit poetry. And at the center of this story is one name, Pingala. In ancient India, there was no separation between mathematics, philosophy, and language. Everything was interconnected. Poetry was not just emotional expression, it was precise, rule-based, and mathematical. This is where Pingala's work becomes revolutionary. Pingala wrote a text called Chanda Shastra, a scientific study of poetic meters. Inside this text, he explains how to construct all possible rhythmic patterns using Lakhu and Guru. Lakhu is 1 unit and Guru is 2 units. This is essentially a binary system in disguise. Think about it. Lakhu is short and 1 unit. Guru is long and 2 units. By combining these, Pingala was counting combinations, encoding patterns using recursive logic. This is very similar to how modern computing works. Later scholars like Virahanka and Halayudha expanded Pingala's work. They described something called Meru Prastara, mountain of numbers. This is a triangular arrangement where top is equal to 1, each row expands, and each number is equal to the sum of the two above it. Today we call this Pascal's triangle. Imagine building this triangle 1, 1 1, 1 2 1, 1 3 3 1, 1 4 6 4 1. This is not just a pattern. It represents binomial coefficients and expansion of expressions like a plus b whole raised to n. So Pingala's tradition was already dealing with binomial expansion, combinatorics, structured recursion. Now comes the most fascinating part. If you look at the shallow diagonals of the triangle which we discussed before, and add the numbers, you get 1, 2, 3, 5, 8, 13. This is the Fibonacci sequence. I'll explain it. 1 plus 1 is equal to 2 plus 3 is equal to 5 plus 8 is equal to 13, and so on. In India, this was called Matra Meru. Why does this happen? Because we are counting the number of ways to arrange syllables where Lakhu is equal to 1 and Guru is equal to 2. For any total length, each pattern will be equal to the combination of previous two lengths. This creates the recursive rule f of n is equal to f of n minus 1 plus f of n minus 2. Without writing a single equation, Pingala's system naturally generates Fibonacci logic. Pingala's work didn't stop at this. It also includes recursive algorithms, which means building new results from previous ones, binomial coefficients, number of combinations, and Meru Prastara. Third one, partial sums of sequences, which means the step-by-step accumulation. Fourth one, geometric series ideas, which means repeated pattern growth. These are concepts that form the foundation of modern algebra, probability, and computer science. Now think about this. All of this was discovered not in isolation but through poetry. In Indian tradition, sound is equal to structure. Structure is equal to pattern, and pattern is equal to mathematics. So poetry became a medium of mathematical thinking. Now centuries later, Leonardo of Pisa introduced the sequence in Europe. But his approach was different. Rabid population problem, arithmetic modeling, written mathematical form. While India approached it through rhythm, sound, and combinatorics. So what's the real takeaway? India was far ahead in recognizing patterns and structures. Before modern mathematics, before equation, before Fibonacci, the logic of numbers was already alive in the rhythm of Sanskrit. So when we look back at everything we just explored, from Pingala to Meru Prastara to the emergence of Fibonacci through Sanskrit patterns, one thing becomes very clear. When we often separate today as literature and mathematics, were never really separate to begin with. In India especially, there is this common idea that if you choose literature as your subject, you're just memorizing things, that it doesn't require logic or deep thinking. But Pingala's work quietly disproves that. Because what appears as poetry is actually built on structure, calculation, and recursive logic. It is thinking in another form. At the same time, mathematics itself was not just something which is limited to numbers on paper. It existed in sound, rhythm, and patterns of language. So the next time someone says literature is just for by-hearting, you already know what to say. Sometimes the deepest mathematics is hidden in the way words are arranged.